the last lecture is the instruction set. Na? So already we have revised what are the different instruction set, what are the different categories, and under that category what different instructions comes for the 8051 microcontroller. And this is one should understand very clearly for the practical point of view, because on the basis of this only instructions only we have to write the programs for different tasks. Okay, so that's why these instructions are very important. So 5 categories are given. In number of books the categories somewhat the naming convention is different, but the main instructions under that category remains the same. Arithmetic, obviously arithmetic operations related to that instructions, logical operations, and apart from that shift left, shift right, likewise data transfer, moving the data, copying the data from source to destination, then boolean variable, bit manipulation instructions which works on an individual bit. Individual bit can be set, reset, clear, likewise complement, and program branching instructions means control is transferred from main routine to another subroutine, and again come back from subroutine to main program or main routine. So for that purpose this program branching instructions are there. So we have completed with this instruction. Now I think I have given a task to write a program to transfer the 5 bytes from one memory location to another memory location. So what we have seen is, first of all, the 2 tasks I think I have given, one by direct addressing mode and one by indirect addressing mode. So first of all, how many of you have tried, at least tried, okay, madam, just we have tried, but we can't write a complete program, or we are not understanding the concept likewise. So tell me your opinion or tell me your experience.
Ma'am, we tried it. Means I
Okay.
have tried it, but the increment operation which is to be performed, I was not able to implement it.
Okay, no problem. Good. I will explain that. Okay, no problem. Yes, any other student? 56 students are there.
Yes, ma'am. I have tried.
You have tried? Can you show me?
Yes, ma'am.
Which method you have followed? Direct or indirect?
Indirect method.
Ariva, good. Yes. Tell me, or just switch on your video or camera and show me your notebook. Just show the program so that everyone can just see the program. And so can you explain the program? Can you able to explain
Yes,
the
ma'am.
program? Okay, try.
Yes, ma'am. Ma'am, first we means R0 and R1 point out केले मी पहिले.
Okay.
त्यानंतर R7 रजिस्टर म्हणून एक हे केला. आपल्याला जर 5 बाईट हे करायचे असतील ना ट्रान्सफर.
Okay.
आता मी इथं 10 बाईट साठी केलेलं आहे 40 to 50.
Okay.
मग जरा मग R0 पॉइंटर सेट करून घ्यायचा 00 वरती.
Okay.
त्यानंतर R0 मध्ये जो डाटा आहे ना तो पहिला अॅक्युम्युलेटर मध्ये सेव्ह करून घ्यायचा.
Okay.
त्यानंतर जो अॅक्युम्युलेटर मध्ये डाटा आहे तो R1 ने जी मेमरी पॉइंट आउट केलेली आहे ना त्यामध्ये ट्रान्सफर करायचा. म्हणजे जो डाटा R0 ला आहे तो R1 मध्ये जाईल, म्हणजे ट्रान्सफर होईल.
कंटेंट डेस्टिनेशनला जातील ना. फर्स्ट फ्रॉम सोर्स टू अॅक्युम्युलेटर अँड देन फ्रॉम
आणि
अॅक्युम्युलेटर
सेकंड अॅक्युम्युलेटर टू
डेस्टिनेशन.
तेच ना R1 ला ट्रान्सफर होतील ते.
ओके.
आणि त्यानंतर R0 अँड R0 इन्क्रीमेंट करायचा. म्हणजे R0 आता जर 40H असेल तर तो 41H होईल.
ओके.
त्यानंतर R1 इन्क्रीमेंट करायचा. तो जर 50H असेल तर तो 51H होईल.
ओके.
म्हणजे 41H चा डाटा 51H ला ट्रान्सफर होईल.
ओके.
मग त्यानंतर डीजे
ओके काउंटर डिक्रीमेंट केला. ओके.
डिक्रीमेंट केला. मग त्याला लूप दिला मी एक. ते लूप 5 टाइम्स रोटेट झालं पाहिजे ना, कारण 5 बिट्स आपल्याला हे करायचे, बाइट्स ट्रान्सफर करायचे. सो ते लूप फॉर्म केले एक तिथे.
ओके गुड. आय थिंक यू आर अ डिप्लोमा स्टुडंट.
या मॅम.
ओके ठीक आहे. नो डाउट. डोंट वरी अबाउट द रेग्युलर स्टुडंट. आय विल एक्सप्लेन. गुड ट्राय. Any other student, I think a regular student who has tried for at least direct addressing mode. Direct addressing mode is very, very simple. Yes, any one student. Direct addressing means what? You have to mention the address itself. So no need to take the pointer and all for direct addressing mode. Are you getting the concept? What we have to write is you have to mention the address, memory address. And that memory address is moved into the destination memory address. Anyone tried for direct addressing mode? Yes, no one? Hello. Or I need to ask randomly the student. Yes. Anyone who has tried the direct addressing mode? Hello? Okay. Can anyone tell me? I want to transfer the 50H memory location content to 60H memory location content. Only 1 byte I want to transfer. How you will write the instruction for the same? Yes? A single task, that is a one content which is available at 50H memory location, that is to be moved to the 60H memory location. Only one task. So who will tell the instruction for the same? Are you getting the task? What is to
Yes,
be
ma'am.
done? Okay. Any other student? Yes. Try it.
Hello, ma'am.
Huh?
We will take the content of 50th location in one register.
Okay.
Then we will copy the content in accumulator,
Hmm.
and then we will copy that content from accumulator to the 60th location,
Okay.
memory
So
location.
directly you have to mention the memory location in that, na?
Yeah.
Yes, you had to mention 50H or you had to mention the 60H. In direct addressing mode, you don't require the pointer. Same is the case, means what happens in direct addressing modes. If I want to move the 10 bytes, I have to write down the 10 memory locations, source as well as destination. If I want to move the 100 bytes, the same TDS job one has to do for direct addressing mode, because we have to mention the memory address directly in the program. But why to go for the indirect addressing mode is by using the pointer, and by using only once the memory initialization, you can go on incrementing the memory location and go on decrementing the pointer. And that's why indirect addressing mode you can easily do. So see, why I'm telling this is, already we have seen the simple program, already we have seen the number of instructions, all the instructions available in 8051. And what I told you, unless and until you do the practice on kill microvision, the concepts will not be clear. So for that purpose I am just focusing you should do the practice of small or simple programs, or whatever doubts you have. Suppose if I write the instruction, I want to write the instruction by this manner, by this method, just write that instruction and run the code, so you will get the error. Then you will come to know what is the error or what is the wrong thing you have done in the instruction. Otherwise the instructions or the mugging up just the instruction, no use for the same. Okay, now see, can you able to see the word file? Yes. Hello.
Yes, ma'am.
Can you able to see the word file? The program for the same 5 bytes transfer from 50H memory location to 60H memory location. Yes. Now see, I will explain now the one by one the instruction. Now see, what is our task? Our task is we have to move the 5 bytes. 5 bytes means 5 numbers which are available in 50H onwards location, to we have to move that into 60H onwards location. Means in this case, what is 50H onwards location? What they are considered as a Yes, in this statement, 50H memory location is considered as a source or destination.
Source.
Source. 50H memory location, 50H onwards, whatever the memory locations you require according to number of bytes you want to transfer. So 50H memory location is considered as a source memory location because from 50H you have to move to the 60H, and obviously 60H memory location is the destination memory location. Now see, I will explain the code one by one. So this is optional, that is org00h. Org already I told. What is this org? Org is nothing but the originate from. It is not an instruction, it is just a assembler directive. org00h means originate from. Your code or your program will start from 000h memory location. Okay. Now in this indirect, why indirect addressing mode is easier one? If you want to transfer the more number of bytes, is already I discussed key, you can take a counter. So see, counter is just a number, how many bytes you want to transfer, that much counter you have to take. So what is my statement? I want to transfer the 5 bytes of numbers. 5 bytes means 5 numbers I want to transfer from 5 memory location, from source 5 memory location to the consecutive destination memory location. So that's why I have written one instruction, move R2. R2 is one of the register. You can take any register from R0 to R7 as it is a pointer, as it is a counter. So you can take any register. Right now I have taken R2 register. So move R2 comma hash 05H. So why I have taken hash 05H? Because 05H is a number. So counter is loaded with the 5. So according to that it will decrement. Okay. So that depends upon what? That depends upon the program statement. How many bytes a user want to transfer from source to destination. Okay. Now see, what I have done is I have to initialize, I have to point to the source memory location and destination memory location. So obviously I have to use the pointer. So which are the registers used as a pointer in 8051? R0 and R1. So see, already I have explained this instruction key, why it is written as hash. Move R0. So first of all, my source memory address. What is my source memory address? 50H. So move R0 hash 50H. Move R1 comma hash 60H. So don't confuse in that hash. If I write @R0 in the consecutive instruction, so this becomes a memory location, though it is initialized by hash. Okay, so R0 is pointed now to 50H memory location. R1 is pointed by 60H memory location. So can I write move R2 comma hash 60H memory location? Yes? Hello, students. Can I write move R2 comma hash 60H memory location? Can I write that instruction? Hello?
No.
No. Why? Because it's one thing is I have taken R2 as a counter. So that is one thing. But for pointer, which are the two dedicated registers in 8051? Either you can use R0 or you can use R1. Here I am requiring the two memory locations, source and destination. That's why I have used R0 as well as R1. So up to these three instructions, any doubt? Any problem? Yes?
No, ma'am. No, ma'am.
No? Can I proceed? Okay. Now, what I have done is I have initialized the counter, very first counter. The counter values is given in the program itself, program statement itself. So according to the program statement, this value may change. But in this way, I have initialized the counter. Then I have initialized the source memory location. Then I have initialized the destination memory location. Okay. Now, what I had to do is, I had to take the 50H memory location into accumulator, and then accumulator content are transferred to 68 memory location. Why is it so, ma'am? Can I directly transfer from 50H to 60H? No. In indirect addressing mode, you can't write the instruction move @R1, comma @R0. So obviously it should be through accumulator. So for that purpose, what you have to do is, first of all, where R0 is pointing now? R0 is pointing to the 50H memory location. So I want that 50H memory location contained to the accumulator. So how I will write an instruction? Move a comma at the rate R0. So can anyone tell me the meaning of this instruction? Yes, according to your understanding. If it is wrong, no problem. Try.
The content present at the memory location R0
Mhm.
pointed by the address
Pointed
R0,
by R0 बोल सकते हो आप.
pointed by R0 is copied in the accumulator.
Yes, exactly. The content of memory location whose address is pointed by R0, because initially we have written R0 as 50H, means obviously the memory location I am talking about is 50H. So content of memory location whose address is pointed by R0 is copied into the accumulator. Means my half task is completed. Source memory location content are copied in accumulator. Now what is the next job? Now I have the content of 50H memory location where? In accumulator. So obviously that accumulator content has to be moved to the 60H memory location. Now see how I have written the instruction. What is my source in this condition? Accumulator, because the contents are available with the accumulator. And where it is to be moved? It is to be moved to the R1, that is at the rate R1. So what is the meaning of this instruction? The content of accumulator are copied to the memory location whose address is pointed by R1. Are you getting all? These are the only two instructions which are very, very important. Yes? So by these two instructions, what happens now? काय झालं या दोन instruction मुळे आता? Hello? Yes?
A to R1.
A to R1 means what exactly?
Content is copied from source to destination.
So in short, you can tell कि 50H content are moved to 60H memory location. Whatever the content available at 50H memory location, they are moved to 60H memory location. Means first byte is moved from source memory location to destination memory location. Yes, understood this concept? Now see. Now what should be done? What should be done now next? Now what should be the next step? Yes, first source memory location contents are transferred to first destination memory location. Now what is the next step? Yes? Next step काय असेल आता?
Incrementing the next memory location.
Incrementing means I have to access the next memory location. Yes or no? I have to access which memory location? 50H is my start memory location. So 51H. So what should be done? Obviously, I have to increment the content memory. Okay. So see, what I have done is I have written the instructions increment R0 and increment R1. So obviously, I have to increment the source memory as well as destination memory. Okay. Now where R0 and R1 pointing? After executing these two increment instruction, R0 is pointing to which memory location? Yes?
51H.
Exactly. R0 is pointing to 51H memory location and R1 is pointing to
61H.
exactly. Yes. So what is the meaning of increment instruction? Always it increment by one only. Yes, so that's why initial value of R0 is 50H, initial value of R1 is 60H. So that's why after incrementing, now R0 is pointing to 51H memory location and R1 is pointing to 61H memory location. Okay, now see what happens. Now one byte is transferred. Now I have to decrement the counter. So can anyone tell what happens if I don't write the counter here? Can anyone tell me the problem, or what is the problem if I don't write the counter?
Only one byte will be transferred. No?
No, but I am writing the instruction increment, na?
Ma'am, infinite loop will be there.
Exactly. The increment instruction has no end. The memory locations will be incremented in infinite time, because we have not restricted to at what location the increment instruction to be used. Are you getting the meaning of this instruction? So for that purpose, counter plays an important role in this program. Okay. So if I don't write the counter, that is, if I not initialize the counter, and if I don't write the decrement instruction, that increment R0 will work infinite times, because there is no limit for that in the program itself. So for that purpose, one has to initialize, user has to initialize the counter depending upon the requirement, means how many bytes user has to transfer from source memory location to destination memory location. Now see, what I have written is decrement instruction. So already we have seen the format of decrement instruction. So what is that basic instruction? DJNZ, decrement jump not 0. So what is to be decremented? R2 is to be decremented. Why only R2? Because I have initialized R2 as a counter. Okay. And to what extent you have to decrement the R2 content? Until it becomes 0. When R2 becomes 0, the condition falls and it will go to the next instruction. Otherwise, it will just remain in that loop only. So this is called as a label. So you can give your name also. Here, this is called as a label. You can give your name also. But from R2, where the control is to be transferred, because these first 3 instructions are the initialization instructions. So we don't want these instructions number of times. Only initialization is done only once. So that's why this label is given to add this instruction. So what happens is, now what is the R2 content? R2 is 5. By executing this instruction, R2 becomes 4. Whether R2 becomes 0? No. Right now R2 is 0. So no need to go to the next instruction. It will jump to the loop only, in that instruction only. Okay, so it will go to the loop. So what is the instruction written and in that loop? So move a comma at the rate R0. Now already you know R0 is pointing to 51H location. So 51H content are moved to the accumulator. Accumulator content are moved to the 61H. Means second byte is transferred from source to destination. Again the same thing happens, or same thing repeats. Again I am incrementing an R0 and R1. So what is the content of R0 now? Yes, Riddhi? What is the content of R0 now? Hello? How 51? I have used the instruction increment. Yes? How it is 51? Means you are not there, you are just physically present, mentally absent. So see, don't do like this. This is for you only, and only 2 lectures are there in a day. Yes, Neeraj? Hello? Hello? Neeraj? Rohit? Hello? What is the content
ma'am.
of memory now? By second iteration?
52H.
52H. Yes, R0 is 52H and R1 is?
R1 is now after incremation it will become 53H.
How 50? R1 is pointing to where?
No, R1 is pointing
62.
to 63H.
Yes, 62.
60,
R1 is
62.
62 and R1 is 52. Again, 52 contents are moved into the 62. So this iteration works till your R2 becomes 0. Yes, so if R2 becomes 0, it will go to the next instruction, and just here, same as that of your wait instruction, or while instruction, it will remain in that instruction only. Yes, jump here and the label is given in that instruction only, so it will wait here. So this is an optional instruction, and end. That's it. Now see, by using this logic, by using this program, you can able to transfer 100 bytes also. Yes or no?
Yes, ma'am.
What will be the change? What will be
Counter.
the change? Yes,
Counter.
you have to just change the counter value. Remaining all things are same. And if the source and destination memory locations are different, according to that you have to do in the program. You have to do the changes in the program. That's it. So that's why this is an indirect addressing mode. Now see, if I want to transfer 5 bytes from source to destination, I can go for direct addressing mode. But if I want to transfer 100 bytes, that much time I have to write all the memory locations and then transfer to that accumulator to destination. So the number of instructions will be more. So no doubt you can go for direct addressing also. Direct addressing is also suitable for memory transfer. But
Ma'am,
what
can
is
you
the
explain the
difference?
direct addressing mode, please?
What is the difference? Yes, what is the difference between direct addressing mode and indirect addressing mode? So that is important here. One should understand. Yes.
Can
Now,
you explain
yes,
with the
yes.
direct
Already,
addressing?
already I told ki how to write the direct addressing mode instruction. So move R0 50H. Okay, 50H content will be transferred to sorry, move a comma 50H. Actually, I don't have the direct addressing mode, but I will explain orally. Because for your program, for your practical, you have to go with the indirect addressing mode. But what is the change? What is the thing is, you have to write, suppose I want to transfer the 5 bytes from source to destination, you have to write the memory location that much number of times. Yes, so that is the change. So move a comma 50H, 50H contents are transferred to accumulator, and move a comma 60H. No need to go for at the rate. Similarly, move a comma 51H, then move 61H comma a, likewise. So that much number of instructions you have to write. There are number of ways, but this is the simple way. Though the direct addressing mode is simple, just you have to write the memory location, content are transferred to accumulator, accumulator content are transferred to destination memory location. So you have to mention the memory address only, 50H, 60H, 51H, 61H, likewise, and up to whatever the bytes you want to transfer. Similarly, same thing happens here. Again, move a comma 52H, means 52H content are transferred to accumulator, and then move 62H comma a. Same repeats, same instructions are repeated. The number of instructions are repeated in direct addressing mode. That's it. In this way, you can write 100 times, but this is not the feasible solution. So that's why we are going for indirect addressing mode. So all of you, first of all, note down this program by understanding. Just don't copy the code. If you are not understood the code, you can just tell me. You can just ask me. And remaining student, just note down the code in your notebook. Yes, Riddhi,
Yes, ma'am.
got the solution now?
Yes, ma'am.
Same thing, same instructions you have to repeat. Means you have to mention the exact memory location in the instruction. Direct memory location is mentioned. So that is the change. And here in indirect, the memory locations are initialized once, and you are going on incrementing the memory location. No need to go for always writing the memory location. Just you are writing the instruction increment. The memory location will be automatically incremented by at each iteration by 1, and you can access that memory location. So note down the program. Remaining students. Harita, are you
Yes,
there?
ma'am.
So what about the code? Are you getting? Any
Yes,
doubt?
ma'am.
Sure,
No, ma'am. Yeah.
sure. Okay.
Yes.
Brunal, hello. Mrunal, are you getting the code? Arey, ask if you are not getting anything. Sanket, Chawan,
Yes, ma'am.
are you getting the code?
Yes, ma'am.
Can you able to write the code now on your own?
Yes, ma'am. I will try.
You will try. Okay, good. Saurabh? Saurabh,
Yes, ma'am.
any doubt?
No, ma'am. No doubt.
Sure.
Yes.
Okay. Now see, this is the first code for your practical turn. So I hope already number of students have installed the Keel Microvision software and you are doing the practice on the same. So you just type the code in Keel and go for stepwise execution. The concept will be more clear if you just write a code and execute a code stepwise. Whatever I have explained one by one the code, same you will experience in the Keel Microvision. What happens exactly for counter, what happens for the memory location, and I will share one video. In that I have explained how to write a code, how to create a project, and how to see the output of this first code, that is the memory transfer. Already I have shown how to get that memory location. You have to go in debug, and in memory window you have to write what you have to type for to get the memory RAM location. Are you remembering? Already I told. Anyone? आपण बघितलं ना मेमरी मध्ये कंटेंट कसं सेव्ह करायचं, हाऊ यू सेव्ह द आन्सर इन मेमरी और हाऊ यू टेक द कंटेंट फ्रॉम मेमरी. So for that purpose you have to search the memory window, and in that what you have to type, how will you get that 50H and 60H memory location? Yes, anyone? झालं त्याला 15 दिवस झाले मॅडम, आता काय आमच्या लक्षात आहे. Anyone?
Ma'am dot ASM.
नाही ग, ते सेव्ह करण्यासाठी आहे. त्या फाईलला सेव्ह करण्यासाठी आपण .asm इन्स्ट्रक्शन वापरतो. बट इफ आय राईट द इन्स्ट्रक्शन, इफ आय राईट अ प्रोग्राम, आय हॅव सेव्ह बाय .asm, I added that program, that all steps are completed, you are getting 0 errors, then you go for debug na. You have to run the program. If you go in the debug mode, you will find the memory window. We will take the memory window, and in memory, how you access the memory location, for that purpose you have to write something in that window.
Ma'am, D0 into 00.
Yes, D colon 2 colon, that is important, and the memory address, either 0 cross 00, or if I want 50H memory location, 0 cross 50H and enter. You will find the 50H memory location at there. Okay, so in this way, and this procedure is given in detail in that video. Just see the video properly and try on your own. Then you will understand the code again in thoroughly. Yes, any doubt regarding this code in direct addressing mode? Any doubt which is not understood, or ma'am, can you please repeat the code, or any doubt? If I write the instruction likewise, why you use this instruction, or any other solution, or any other suggestion, madam, can we write this program by this method, by this logic? Do you have any such doubt or suggestion? They are welcome.
Hello, ma'am.
Huh?
SJMP instruction is optional, na?
ऑप्शनल. एस जम्प म्हणजे काय, आपण काय बघितलं तर त्या इन्स्ट्रक्शनचा मीनिंग शॉर्ट जम्प. मग आता कुठे जम्प करणार, पुढे लेबल जे लिहिलेलं असतं ना, सो दिस इज कॉल्ड एज अ लेबल. दिस इज कॉल्ड एज अ लेबल. कुठे जम्प करा, हिअरला. हिअर हे एक लेबल आहे, सो इट विल सर्च फॉर दॅट हिअर लेबल. सो वेअर आय हॅव रिटन हिअर इन दॅट इन्स्ट्रक्शन ओनली. म्हणजे ह्या इन्स्ट्रक्शनचा मीनिंग काय झाला, कंट्रोल तिथंच राहणार. येस, हे ऑप्शनल आहे, हे नाही लिहिलं तरी चालणार आहे. काही ऍप्लिकेशन्स मध्ये, फॉर सम ऍप्लिकेशन, इफ यू रिक्वायर कंट्रोल इज टू बी ट्रान्सफर टू दॅट इन्स्ट्रक्शन ओनली, or you have to wait at that instruction, then you can use the instruction. This is just like a while one likewise in your C. That's it.
Okay, ma'am.
Okay. Any other doubt? ORG and end are not the instructions. Have you seen end as an instruction in instruction set? Whether we have studied end as an instruction? Yes or no? Forgot, ma'am. Don't remember whether we have studied end or not. So this is very common question asked in your oral exam. What is end and what is ORG? So immediately you answer the question, ki ma'am, ORG is an instruction. End is also an instruction. ORG and end are not the instructions. They are assembler directives. Gives the direction about the originate of your program, origin location of your program, and end of the program. So that's why ORG and end are not the instructions. Okay. Now, just take one more statement. Write down in your notebook. Everyone copied the code, written the code in your notebook. Yes? Okay.
Yes,
Write
ma'am.
down.
Yes, ma'am.
Write down the second statement. Write ALP. What is ALP? I think already I explained. Arithmetic language program. So in your exam also, you will find this word ALP. Sorry, not arithmetic, sorry. Assembly language program. So short form is ALP. So write ALP to transfer 5 bytes of data from internal RAM location 50H to external RAM location 0100H onwards. So first of all, copy the statement or write down the statement. Yes? Copied the statement?
No, ma'am, yet.
No yet, okay. Once you finish, tell me. Hello?
Ma'am, can you please open that tab? It is not the.
Okay. Now it is visible?
Yes, ma'am.
So see, just run this code or experience the output of this code by using Keel software. Then again, you will find the interest in this. So this is just the oral description about the same. So if you experience actual output in the Keel microvision, so the ideas will be more clear. And you have to tell that me in the next lecture. So or you have to tell your experience, what you understand, and do you need any changes in the code, that you have to tell in the next lecture. Now tell me, what is the difference in the previous code and this code or this problem statement?
We have
Do
to
you
shift it to
understand?
external RAM location. In the previous
What?
one, it was in the internal RAM location only.
So previous was internal to internal. The memory transfer or content transfer, both means what? Source and destination memory, both are internal memory locations in the previous code. Now what happens? The source memory is internal and the destination memory is external memory location. Yes or no? Or I'm telling opposite. Whether it is correct? Source is internal, na?
Yes, ma'am.
Source is internal and destination is external. Okay. Now, can you just tell me, if you understand the first code properly, can you just tell me what will be the change in this code? Because this code will be near about same as the previous one. But what will be the change? A minute change. If you understand the instruction set clearly or understand the meaning of instructions for this particular task. Anyone?
Ma'am, we have to use MOVX for extend.
Exactly. Why we have to use the MOVX instruction? Because we have to access the external memory location. And so as to access the external memory location, which instruction is available in 8051? MOVX instruction. So that is very important thing. At least before trying this code, you should understand this concept. Remaining all part are almost same. Remaining all code is almost same. So just try this code at your own, and in the next lecture we will discuss the code for the same. Okay. Now first of all, write down the statement for third task. That is, write the ALB. So I will dictate the statement. Write ALP. Yes, everyone write down the third task because they are similar. Write ALP to transfer 5 bytes of data. This statement is same from external RAM location. From external RAM location 0100H. Write ALP to transfer 5 bytes of data. This is same statement from external RAM location 0100H to external RAM location 0100H to internal RAM location 50H onwards. Internal RAM location 50H onwards. Means what is the third task? Yes? What is the third task? Or what is the difference between second and third task?
In this source is external memory.
Yes, source is external memory and destination is internal memory. Means see, first was what I have explained the code for that is, it was transfer between internal to internal. Second was internal to external. Third was external to internal. Now what will be the last, or what should be the last option? Can you guess?
External.
Exactly, external to external means source as well as destination, both are external memory location. So yes, in a single practical, that is the first practical, these 4 codes are there, that is to be assembly code. Okay, so try this code on your own. Try to write the code at least for second and third task. External to external, I will going to explain in the next lecture. But try this code on your own. Then you will understand the concept. Okay, so this is about the first practical, and why I have started the first practical, why I have taken this first practical is, whatever the theory part we have completed for 8051, if you execute these codes, you will get the idea about that theory part, or you will just understand the theory concept more clearly. So that's why in between I have taken the first practical, which is very very simple, and you don't require the kit for the same. This is just a simulation. You don't require any 8051 hardware kit. For here onwards, whatever the practicals are there, LED interfacing, LCD interfacing, you should require a kit. So for that purpose, these practicals right now we can't conduct. So for that purpose only I have taken this first practical. But the thing is, you should practice this code on your own by using Keel Microvision 4 software. Already I have given the steps. I have explained how to use that. Again, I am sharing the video for the first practical, that is internal to internal memory transfer from start to end. Just creating a project, writing a code, and up to how you observe the contents are transferred or not. So I will share that video. Okay? Yes, any doubt about the second and third task? Any problem or anything which is not understood related to the task or concept? Yes, Trupti? Any
Yes, ma'am.
doubt? Any doubt regarding second and third task?
No, ma'am.
What is third task?
I have taken the screenshot only.
Why? But I have explained orally also, no?
Yes,
What is the third task? But for third task, the screenshot was not there, because again I have just shown presented the second task only, and I have orally dictated the third task. काय तृप्ती, झोप झाली नाही का अजून?
झाले मॅम.
काय ग असं करता तुम्ही लोक? परत तुम्हाला बोलल्यावर पण राग येतो की नाही? हे सारख्या रागवतच असतात. असं करू नका, तुमच्यासाठी आहे. तुम्हाला मी सांगितलं ऑलरेडी की इन द सेम सब्जेक्ट you have to write the assembly code as well as C code. So just try this code on your own, take interest in that, ask questions, do the practice. So this is for you only. Okay. Okay. So thank you all. We will stop here. I think the next lecture is the Male ma'am's lecture. So ma'am has given the link, share the link.
Yes, ma'am.
Okay, so you can leave the meeting. Okay. Thank you all.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you.